The constellation Pavo hides an incredible object within it, an exact twin of our Milky Way. And one of its stars is so similar to the Sun that they actively search for extraterrestrial life there. But the constellation got its name from a macabre ancient Greek myth about the hundred-eyed giant Argus. After the giant's death, the goddess Hera placed all 100 of his eyes on the peacock's magnificent tail.
Today, we're venturing deep into the southern celestial hemisphere to get acquainted with the constellation Pavo, the Peacock. Now, if you're in the northern hemisphere, chances are you've never actually seen it. And that's part of what makes it so interesting. Pavo holds some absolutely incredible stories, linking the life cycle of stars to the great age of discovery. Believe it or not, the answer to that question is written in the stars of this one single constellation. In this explainer, we're going to see how Pavo connects the dots between astrophysics, global history, and even ancient myth. It's truly a crossroads in the sky, and we're about to explore every single turn. All right, first things first, we need to get our bearings. We'll start with the fundamentals. Where exactly is Pavo in the sky, and who on Earth can even see it? This is absolutely crucial to understanding its entire story, because for thousands of years, most of the world had no idea it was even there. So just how big is Pavo? Well, it carves out a piece of the sky that's just under 378 square degrees. That makes it the 44th largest of the 88 modern constellations. Pretty respectable, right? In the middle of the pack. It's a solid patch of celestial real estate, and on a perfect night, you could spot about 87 of its stars with just your eyes. Okay, to really understand its visibility, picture a globe. If you're standing anywhere south of the 15th parallel north, that's a line that slices through Central America, the heart of Africa, and South Asia. You get the full show. The entire constellation of Pavo rises above your horizon. For anyone in the southern hemisphere, it's a staple of the night sky. Now, let's travel north a bit, into this temperate zone between 15 and 34 degrees north latitude. This is where things get a little tricky. If you're in, say, southern Texas or North Africa, Pavo starts to sink really low on that southern horizon. You might just catch its highest stars skimming the skyline, but a huge part of it is just gone, forever hidden from your view. And if you go any farther north than that, we're talking places like Los Angeles, Tokyo, pretty much all of Europe. Pavo is a complete no-show. It is always below the horizon 24/7. And that simple fact of celestial mechanics is the reason why this incredible constellation was completely unknown to European astronomers for millennia. Okay, so we've mapped out Pavo's territory. Now let's zoom in and meet some of its most famous residents, the stars themselves. These aren't just random points of light, no. Each one is like its own natural physics laboratory, teaching us how stars work. And trust me, Pavo has some truly fascinating case studies. Talk about a tale of two stars. On one side, you have Alpha Pavonis, and its nickname is Peacock. It definitely earns the name. This thing is a monster, a furiously hot, brilliant blue-white star. It's a true powerhouse, 6 times the mass of our sun and blazing 2,200 times brighter. But then you look at Delta Pavonis. It's a G-class star, a much cooler, more stable yellow star, a lot like our own sun. And get this, it's just under 20 light-years away. That's practically our next-door neighbor, cosmically speaking. It's so similar to our sun and so close, it's become a prime target for SETI programs looking for life out there. If you want a little preview of our own solar system's distant future, just look at the star Phi 2 Pavonis. It's another star that's a lot like our sun, but it's much further along in its life. It's already burned through the hydrogen fuel in its core, and now it's starting to puff up. It's in the subgiant phase. Imagine its outer layers of gas swelling, pushing outward. Any planets that might be orbiting it are now on borrowed time, facing total destruction. It's a powerful, real-time look at a star's life cycle. All right, let's push our focus even deeper now. We're going to look past Pavo's stars into the unimaginable void behind them, because out there, millions of light-years farther away, are massive collections of stars and entire galaxies that add another incredible layer to this story. And here we have NGC 6752. This object is just magnificent. If you look at it with a pair of binoculars, it's really just a hazy patch of light. But if you point a telescope at it, that patch resolves into a breathtaking, glittering sphere of hundreds of thousands of stars, all packed into a space only 100 light-years across. It's like you're looking at a dense, ancient city made of stars, all bound together by gravity. And next up is NGC 6744. This one is fascinating because astronomers call it an analog galaxy. Why? Because its structure, with that central bar of stars and even a small satellite galaxy orbiting it, is almost a perfect mirror image of our own Milky Way. And studying it gives us this amazing external view of what our home galaxy probably looks like from 30 million light-years away. It's like getting a selfie of the Milky Way. Okay, so we've looked at the physics of Pavo. Now we're going to pivot to the human story. The story of how this pattern of stars was first charted, how it was named, and how it was filled with meaning. Pavo is actually a pretty modern constellation, born straight out of the age of discovery. Its stars were first charted by a Dutch navigator named Pieter Keyser during a really dangerous trade mission to the East Indies in the 1590s. When the cartographer Petrus Plancius got Keyser's new star charts, he also saw all the exotic goods being brought back from these voyages, including the absolutely stunning Javanese peacock. It's believed he named the constellation after this magnificent bird, forever linking the new stars being discovered in the heavens with the new wonders being found on Earth. So even though the constellation is modern, it got retroactively tied to a powerful ancient Greek myth. The story is all about deception. Zeus transforms his lover, Io, into a cow to hide her from his wife Hera. But Hera isn't fooled. She puts her ultimate guard on the job, the giant Argus Panoptes, the all-seeing, who had 100 eyes that never all slept at once. Well, the god Hermes disguised himself as a shepherd and managed to lull all 100 of Argus of eyes to sleep with stories and music. Then he killed him. The story goes that a grieving Hera, to honor her faithful guard, placed his 100 eyes onto the tail of her sacred bird, the peacock. All right, let's bring everything together. We're going to see how Pavo isn't just an object for scientists and historians to study, but also an incredibly practical tool for actually finding your way in the world. You see, in the southern hemisphere, there's no bright pole star like Polaris to guide you, but Pavo offers a pretty clever solution. 6 of its stars form this very distinct saucepan shape. Now, if you imagine a line extending out from the 2 stars on the right side of the pan, and then another line extending from the 2 stars that form the base of the handle, the point where those 2 imaginary lines cross in the sky is the south celestial pole, the exact pivot point the entire southern sky turns around. And when you put it all together, you realize Pavo is a true paradox. It's a single point in the sky that connects the biology of the East Indies, the history of European navigation, and ancient Greek ideas about seeing and being seen. It's both a map to the stars and, really, a map of human curiosity. And that leaves us with one final thought. The night sky is not just a collection of physical objects. It's a cultural and scientific archive. Pavo shows us that every constellation is a layered text, just waiting to be read. So the real question is, what other stories are waiting for us up there in the stars?
Thank you, friends. Strive for understanding and become wiser. See you soon.